Hello students, welcome to section 18. In this section, we are going to do some questions from practice set 2.5 that we stopped at in the previous section. So I have question number 5 from page number 50. This is question number 5. The question states that the sum of the roots of a quadratic equation is double their product. That means we have a relation between alpha plus beta because alpha plus beta is the sum of our roots. Alpha plus beta is equals to, and here on this side I have alpha beta, and there is some relation between these two terms. Now the question states sum of the roots of a quadratic equation is double their product. That means double their product, that means 2 times the product. So the value of 2 is going to be on the right hand side along with the product of the roots. Now the next statement says find k if the equation is x square minus 4kx plus k plus 3 is equals to 0. So we have to find the value of k for the given quadratic equation x square minus 4kx plus k plus 3 is equals to 0. Now one thing we need to note is that k plus 3 is a constant over here. K is not associated with the term x because there is no x term multiplied with the k that has been added to the value 3. So now we have to compare this equation to our standard form first. So by comparing to standard equation, we get a is equals to 1, b is equals to minus 4k, and c is equals to k plus 3. So alpha plus beta is given by minus b by a. This is equals to minus 4k. This is minus of minus 4k because minus of b. Our b is already negative, so there we'll have two negative, one inside the bracket, one outside the bracket. Our value for a is 1, so this term comes as 4k. Now alpha beta is given by c by a. Value of c is k plus 3 and the value of a is 1. So now we have these two values from alpha plus beta and alpha beta. Now we are going to substitute this in our equation 1, which is already given in the question. So we have 4k is equals to 2 times alpha beta. I'll rewrite this so that all of you understand. So we have alpha plus beta is equals to 2 times alpha beta. My alpha plus beta value was 4k. So all I need to do is substitute the values in this equation. So I have 4k is equals to 2 times k plus 3. This implies 4k is equals to 2k plus 6. Taking 2k to the left hand side, I am left with 2k on the left hand side. This is equals to 6. So my value for k becomes 3. This is a pretty simple question. All we need to do is focus on the words given in the word problem. Moving on to our question number 6. Now this question needs a lot more understanding for the formulas that I told you to revise, the identities for a plus b whole cube, a minus b whole cube, a plus b whole square, and a minus b whole square. In this particular question, I'm going to solve the sub question 1 from question number 6. Sub question 2 is for you to solve. I'll be, however, helping you out in order to understand how to solve this equation. So the question number 6 states that we have a quadratic equation y square minus 2y minus 7 is equals to 0. And in sub question 1, we need to find the values of alpha square plus beta square. Now bear in mind this value is absolutely not equal to alpha plus beta whole square. These are two different identities and we'll see how. So using our identity a plus b whole square, we get a square plus b square plus 2ab. So now instead of a, I have alpha, and instead of b, I have beta. So I can write down alpha square plus beta square plus 2 times alpha into beta is equals to alpha plus beta whole square. Now remember, we only need this term from our question. So what I'm going to do is I'm going to keep this particular term on the left hand side, and anything else that is remaining on the left hand side has to be shifted to the right hand side. So in the next step, I have alpha square plus beta square is equals to alpha plus beta whole square minus 2 times alpha beta. Now we have our quadratic equation. When we compare our quadratic equation to our standard equation, we get the value of a is equals to 1, b is equals to minus 2, and c is equals to minus 7. Now that means alpha plus beta is equals to minus b by a, which is equals to minus of minus 2 divided by 1, and alpha beta is equals to c by a, which is equals to minus 7 divided by 1, which is equals to minus 1. The alpha plus beta value becomes plus 2, and now all we need to do is substitute the values for alpha plus beta and alpha beta in our this equation 1 that we just received by shifting the values from left to right. So all we need to do is put the values in the equation. So I have x alpha square plus beta square is equals to alpha plus beta, that is 2 whole square, minus 2 times the value of alpha beta is minus 7. So this is equals to 2 square is 4, minus 2 into minus 7 is plus 14. Therefore alpha square plus beta square is equals to 18. So this is my solution for this particular sub question. For alpha cube plus beta cube, you similarly have to use the same concept and same rules, but instead of using this formula, you have to use the formula for a plus b whole cube. Now, moving on to question number 7, we have the roots of each of the following quadratic equation are real and equal. Find the value of k. So I won't be solving this question because this question is quite easy and you all should be able to solve this, because all we need to do is to make sure that our discriminant value, which is delta, is equals to b square minus 4ac, is equals to 0. Now we need to substitute the values of b, a and c and equate it to 0, and you will get the value for k. So now we'll be moving on to word problems from page number 50. In this particular section, we'll be doing just one word problem in order for us to understand how to approach word problems. We have already tried this in the linear equations, but in order to perfect our understanding for word problems, we need to keep practicing as many word problems as we can. So now this is our solved example from page number 50. This is page number 50, solved example number 1. The question states that there is a rectangular onion storehouse in the farm of Mr. Ratnakarao at Tivasa. Now, one thing that we need to understand is that there is some trivial information here that we do not need at all. The only thing that matters is the information that we need, the mathematical information that we need, because like let me rephrase this. A storehouse has no mathematical value. A farm has no mathematical value. Mr. Ratnakarao has no mathematical value. And Tivasa has no mathematical value. The only mathematical value that there is in the first sentence is the rectangular onion storehouse. That means the storehouse is in the shape of a rectangle. So the first step is to draw a rectangle. So this is the only information that is needed from the first sentence. Rest all is just something that is needed to complete a sentence and needs to be made and needs to make the sentence correct grammarly. Now moving on to our second sentence, we have the length of a rectangular base is more than its breadth by 7 meters. That means the statement is saying that length is 7 more than the breadth, and the diagonal is more than the length by 1 meter. That means we need to draw a diagonal in this case. So here is my diagonal. Make sure you name your sides. It does not matter which sides what letters you choose. All that matters is that your sequence should be correct. So I have A, B, C, D. Now remember, in linear equations, as I talked, that always assume the smallest value as x. So as we know in rectangles, the breadth is the smallest distance. So I'm going to assume the breadth as x. So I am going to say let the breadth be x. Now the statement says, the second statement in our word problem says that the length of the rectangular base is more than. That means if I am talking about length, it is equated to more than its breadth. So more than means there is going to be a plus sign involved, and its breadth is x, and the value that it is more than by is 7. So the value of length is x plus 7 meters. Now the next statement says that the diagonal is more than the length by 1 meter. That means the diagonal is equals to, more than means again there is a plus sign involved, and the value that it is more than by is 1, and the value of length is x plus 7. So the value of diagonal becomes x plus 8 meters. Now as we know that rectangle, if you draw a diagonal along a rectangle, then it forms two right angle triangles. So in this case, the value of BC becomes x, the value of BC becomes x, the value of DC becomes x plus 7, and the value of BD becomes x plus 8. So as we know, in right angle triangle, we can always apply Pythagoras theorem. So all we need to do is apply Pythagoras theorem. So here, by Pythagoras theorem, we get BC square plus DC square, BC square plus DC square is equals to BD square. So my BC value is x, so here it is x square, plus my DC value is x plus 7, so this is x plus 7 whole square, and my BD value is x plus 8, so this is x plus 8 whole square. Now all I need to do is to expand the brackets and solve them simultaneously. So this becomes x square plus, this is in the form a plus b whole square, so I get x square plus 7 square is 49 plus 2 times ab. In this case, my a value is x and my b value is 7. So my 2ab value becomes 14x, and on the right hand side I have x square plus 64 plus 8 into 2x is 16x. Now before we start solving this, we need to make sure that we cancel everything that there is to cancel. So as we can see, I have 1x square here and 1x square here, so this straight away cancels up. Now anything that we cannot cancel has to be moved and to be solved. So here I get x square plus 49 minus 64 plus 14x minus 16x is equals to 0. Now here I have a quadratic equation, and now we can use any method, factorization, completing the square, or formula method. You can choose any one you want, whichever suits you or whichever you find easy to use, and you can solve the quadratic equation using any one of those methods. So I have x square minus 2x, and here I have minus 15 is equals to 0. X square minus 2x minus 15 is equals to 0. In this case, I'm going to use factorization method. So the product of A and C here is minus 15, and the sum of term here is minus 2. So I can write as minus 5 and plus 3. So this becomes x square minus 5x plus 3x minus 15 is equals to 0. So this is x into x minus 5 plus 3 into x minus 5 is equals to 0. This implies that I have x plus 3 into x minus 5 is equals to 0. So therefore, either x plus 3 has to be equal to 0 or x minus 5 has to be equal to 0. This implies x is equals to minus 3 meters or x has to be equal to 5 meters. Now, one of these solution is wrong, and we are going to see why. Whenever, let's say, let's take a student. Let's say I have a student named Abhay Singh, and his height is let's say 170 centimeters. Whenever we talk about height, we always say 170 centimeters, and we know that whenever there is no sign in front of a number, we have to assume that the sign there is positive. So if you talk to somebody, your friend or your teacher or your parent, and you say what is your height, you will never hear anybody say my height is minus 150 centimeters, or my height is minus 6 feet, or the building is minus 10 meters tall. So this means that length can never be negative. Length can never be negative. So if length can never be negative, that means this solution becomes completely not usable. So I am left with x is equals to 5 meter. Now remember, when we started, my breadth was x, my length was x plus 7. So this is equals to my breadth, and x plus 7 is equals to 5 plus 12. So 5 plus 7 rather, which is equals to 12 meter, which is equals to length. And similarly, you can find the value for diagonal. Now, one thing that is absolutely crucial here is that you have to write this particular SI unit here. If you do not write meter, you're going to lose at least half a mark, because here we are talking about length, so therefore the value has to be in meters. If the question states in kilograms, then you have to write the SI unit as kilograms in front of your answer. If the question states as rupees, then you have to write rupees in front of your final answer, else you're going to lose some marks for missing the SI unit. I hope this section was helpful for you. In the next section, we'll be moving on to some much more complicated questions that are given in the textbook, and we'll be completing practice set 2.6, and then after that section, we'll be moving on to maths 2. Thank you, and this section ends now.